Good morning, students. Hello. Hello.
Good morning, sir.
Good,
Yeah.
good morning, sir.
Yeah, I'm
Good
all audible now.
morning, sir.
Good morning, sir.
Yes.
So let us start. Can you see the presentation? Yes.
Yes, sir.
Okay.
Sir.
So if you are having some doubts or something like that, please do ask me. Okay. So today we'll be discussing the Hooke's law. Yesterday I just gave you a hint about it, right? So what is Hooke's law actually? As per Hooke's law, it states that stress is directly proportional to strain. Okay, Hooke's law states that stress is directly proportional to strain. Now, the stress is denoted by sigma, okay, and strain by epsilon. That means what? Here, stress, as per the Hooke's law, this sigma is directly proportional to this, which is what? Epsilon, right? So now, if these two are directly proportional to each other, then what will happen? Then we'll have a constant of proportionality, which is known as Young's modulus. Because these are two proportional, so in order to show that these are equal, we'll be multiplying it with a constant of proportionality, so which is known as what? Young's modulus. Now, if you pay attention, the stress and strain for different material will be different. Yes or no? Stress and strain for different materials. Suppose this is sigma, stress and strain. So and strain. So what this we can write like this. Yes or no? So stress by strain we can write it as Young's modulus E. Now if you see here what happens, if you see here what happens, stress sigma is equal to, you all know what is sigma. This is equal to force or unit area, right? Stress is equal to force per unit area, and strain is equal to change in length by actual length, right? Now if you see here the Young's modulus, it is dependent upon the property of the material. Why? Because this force per unit area that is applied on the material will be different, and For different materials, this deformation del L by L ratio will be different because we apply certain amount of force on the material and it gets deformed. So definitely this will be different. So that is why we get the value of E. That means the Young's modulus or the value of constant of proportionality for Hooke's law. Which is E. It is different for different materials. Now it has been experimentally determined by Thomas Young, okay, for a number of materials. As I said before, these are different for different materials. So it is defined by Thomas Young. Okay. Now he found that the constant of proportionality is unique for every material. That's what I say. For different materials, this constant is unique. Okay. Therefore, this is known as Young's modulus, or even you can say it as modulus of elasticity. Therefore, Hooke's law is further modified as like this: ratio of stress to strain. Because it is proportional, that is why this is a straight line. So this is a straight line. That means P by A. Just now we discussed F by A. Now F, yesterday I said F and and P are what? F and P are same things, just they are denoted differently. Just they are denoted differently. That is why we are writing this as P by A like this. Okay. Now this is the expression PL by A is the expression for del L. Okay. So in this way we get the expression. Now let us see the stress strain diagram. This is a very important diagram. So stress strain diagram for a ductile material. So if you see here the stress strain diagram, the Hooke's law remains valid up to a certain point. Beyond that, the Hooke's law does not remain valid. If you can see from the diagram. So why does it happen? It happens because of the amount of varying amount of stress and strain. Now, hello. Yeah, please mute your mic. Chuba, please mute your mic. Whoever is speaking, please mute your mic. So in this way, it is different. Now, if you see from point 0 to A, so from point 0 O to A or 0 to A, once the stress and strain it gets varied, it is directly proportional. Someone is speaking, please mute your mics. Yeah, whoever is speaking, please mute your mic. What? Hello? Hello? Mechuba Longsar, please mute your mic. Someone please ask him to mute his mic. It's very disturbing. You should. Yeah. So this is known as limit of proportionality. Okay. Now beyond that range, beyond that range, if you see, it is known as elastic limit. Now look. Now we will discuss regarding this graph in detail. Now if you see here, number one is what? Proportional limit. The proportional limit is valid from this O to A. So look, showing point A as proportional limit. Okay. Now after point A to B, after point A to point B, it is known as what? Elastic limit. So it is known as elastic limit, the point B. Now after point B, there is point C, where you can see here. If you see it here, this is called upper yield point, and point D is called what? Point D is called lower yield point. Okay, so in this way, it is different for different points. Now at point F, at point F, here it is known as rupture. Rupture means what? Rupture means the point beyond which the material cannot hold any stress, and eventually it will what? It will fail or break down. So this is known as rupture. Now if you can see here, it is proportional limit. Huh? The first one is what? Proportional limit. Then the second one, is called elastic limit. Now the proportional limit is what? With the proportional limit, if you can see from the diagram, the stress is, it is a straight line, right? Here it is a straight line, if you can see here. Huh? So if it is a straight line here, that means what? The stress is directly proportional to strain. Okay, is it clear for everyone? Then huh, after that, the stress is directly proportional to strain. We get elastic limit. Elastic limit is the next part. After suppose proportional limit is happening. Huh? Okay, so you are applying stress here. Stress means what? Force per unit area in this direction. That means what? You are increasing the stress. So when you are increasing the stress, Up to this point, the stress and strain are directly proportional. After that, you increase the stress, it will reach point B. Ah, point B means what? It is the elastic limit. Now, that means in elastic limit, what happens? Like up to this point B, up to this point B, if you apply stress, then the material will behave as a elastic material. Now, do you know what is an elastic material? Can anyone say me? What is an elastic material? Can anyone say me?
Regain its original shape.
It regain its original shape. Okay. Anyone else want to say?
And size.
Mm-hmm. Temazar, please speak. What you said? I'm not able to hear you, Temazar.
Original shape and size.
Okay, shape and size is fine. Anyone else? Can anyone else want to say, add to it? No? Okay, fine. So, what is elastic limit actually? In elastic limit, once you start applying stress, huh, once the stress is increasing, first of all, it comes to a proportional limit that stress is directly proportional to strain. After that, it reaches the elastic limit. Now, in elastic limit, what happens? Suppose you are applying stress. Stress means what? Force per unit area. So once you keep on applying stress there, what will happen? It will come back to its original position. Okay. So there, suppose you are applying stress and then suddenly you remove it. After you remove the stress, it will come back to its original position. That's what they have seen. Okay. So this is what is known as elastic limit. Now, look, if you see, then point number C. Huh, yielding. After that, it will yield. After point B, if you keep on applying stress, the material will yield a little bit and then it will come down. That means the stresses will come down, but the strain will increase. Okay. So that means what? In yielding, what happens? The load, that is, the load will be reduced, but the material will continuously deform. So between point C and D, what will happen? The load is decreasing. Look, the load, that means stress is decreasing. But then there is strain. You can see some amount of inclination in this graph. That means what? Here is certain amount of strain. So which means that the material is deforming, but certain amount of strain is being applied. So this is how it will come to the upper and lower yield point. Okay. Now at the lower yield point, that is point number D, it is the point from which plastic deformation start place. Now what is the difference between elastic and plastic? Please say, can anyone? Difference between elastic and plastic deformation. Can anyone say? Can anyone say? Can anyone say what is elastic and what is plastic deformation? No? I'm not getting any answers. Are you people hearing me what I'm saying? Students, are you people hearing me what I'm saying?
Sir.
Yeah. So then say me an answer. If you know, if you don't know, you say don't know. What do you do? Do you know the difference between elastic and plastic? If you don't know, you say don't know.
The materials that change shape is plastic,
The material. What you said, Nishita?
and the materials which change shape
Hmm.
and the materials that regain its original shape is elastic.
Okay, very good. So that means what? Zambe, Wangchu, and Nishita gave the correct answer. So that means what? Ah, what is plastic and what is elastic? Now in elastic, you have seen a rubber band, right? Every one of you have seen an elastic rubber bands, right? So what happens in a rubber band? The if you just pull it, it comes back to its original shape. That is elastic thing. Huh? Now in plastic, what happens? If you take a plastic scale with you, now you apply force, keep on applying it, and eventually what? It breaks. But if you remove now, if you stop applying force, it breaks down, but it does not comes back to its original shape. This is known as plastic, and the previous one was known as elastic. Can you get me now? What is the difference between elastic and plastic? Can you get me now,
Yes, sir.
students? Yeah, good. So that means what? In this point, now let us go to this context. In this point, the C and D. Look, there is a downward shift of the graph. That means what? The force applied or the stress is reduced, but there is strain. And beyond this point, the material does not come back to its original shape. So that is known as the plastic zone. Okay. Now this is the yield point. Yeah. Any doubt? Anyone? Any doubt? Jambe? Any doubt? Jambe Wangchu? Any doubt? So we go to the next one, which is known as ultimate stress. So ultimate stress.
Hello, sir.
Yeah, please.
Why, sir, elasticity of the iron steel is greater than a rubber?
Why is elasticity of steel is greater than rubber? Now this is dependent upon the property of the material. Okay. Now look, if you try to pull a rubber, what happens? Now I'm giving you an example. Elasticity is the what? Actually, elasticity is what? It is the ratio of stress and strain, right? Now, for a given stress, that means force per unit area, it gives the less amount of deformation. Now, I'm giving an example. Just wait. Now, we know ratio of stress to strain. Hmm. That means what? Force per unit area. So this is stress, and we have to divide it by del L by L. Now, if you take a particular material of rubber and if you take a particular piece of rubber and steel and apply the same amount of force, now the area is also same. So what happens? If you try applying some force on a steel and on a rubber, Then if you apply some force on a rubber, what will happen? The rubber will elongate more. Yes or no? So rubber will elongate more. That means what?
Yes, sir.
Del L for rubber will be more. Right. The del L for rubber or elastic will be more.
Yes, sir.
But if you apply the same amount of force in steel, the del L is almost negligible. There will be no change in length. Now try dividing these two. Now try finding out the E or Young's modulus, or what will happen? The elasticity value or E of definitely steel will be more. That is why. Is it clear? Temazar, are you clear
Yes,
now?
sir.
You
Yes,
understand
sir.
now? So technically this is the thing, main thing. Now you apply some force, there will be difference in del L. No? So the reason which plays in this more elastic, less elastic thing is del L. Clear now? Okay, is it clear now?
Yes. Yes,
Okay,
sir.
good. Now let's come to ultimate stress. Ultimate stress means what? Ultimate stress is the maximum amount of stress. That means the maximum amount of force per unit area that a material can bear. They're applying stress on a particular material. Now it keeps on elongating. Now there will be a point before breaking, just before breaking, the elongation point or the stress that it can resist. Huh? That is known as the ultimate stress. And finally, rupture. Rupture means what? The stress at which the material eventually fades. Clear? Are you clear with these things? I'm asking every one of you.
Yeah.
Clear with these things?
Sir.
Yeah, please speak. You are clear? Are you clear?
Yes, sir.
Okay, good. And what about others? No one is responding. So it seems to be clear to everyone, I guess. Is it clear for everyone?
Yes, sir.
Okay. Then it's okay.
Yes, sir.
So far it is clear. So far it is clear. Now I'm showing you a PPT. It will be more clear with you. Wait a minute. Huh? Now in this stress strain curve, can you understand which one is elastic zone and which one is plastic zone from this graph? Just now I showed you one graph now. So there is one point it where the graph like this. It rises and it comes down. That point is known as yield point. That point is known as the yield point. And beyond that yield point, that means what? Beyond that yield point, the material is said to be behaving as a plastic. So this is the definition. So when elastic behavior is what? When the material will, someone said, no, material will return to its original shape when unloaded. Unloaded means what? When you remove the stress or when you remove the load, then it will return back to its original shape and size. Got it? Then plastic behavior. Now in plastic behavior, the materials will retain some deformation. That means what? They will not come back to its original shape. That is known as plastic. Now, structural members are designed as elastic members. So when you will get back, we'll get this design sort of things in the higher semesters. Now, I'm just giving an introduction. So when you design a structural member, do you know what is a structural member? Can anyone say what is a structural member of a building? Since you are with civil, so I'm making this subject more oriented to civil. Then it will be interesting for you people also. Can you tell me what is a structural member? Anyone? Hello?
The
Hello?
object which we use to structure or construct something.
No. Suraj Bora has given the correct answer. Good. Suraj, you are correct. It is a column and beam. So look, structural members, not a constructed structure. These are the basic parts of a building. Suppose in case of structural thing, it's just a structural analysis and design. In civil engineering, a structural member means what? Column and beam. Do you know what is a column and beam? So a column is what? The vertical members in the building or supporting members that are known as column. And the beams are horizontal members. Okay? Where I'm showing you. So here, this is a column. This is a column. And these are the beams. So these are the structural members. Is it clear? Is it clear, everyone? Apart
Yes,
from this,
sir.
so this, can you recall? Will you remember which one is column and which one is beam in a building? So this is column. This is beam.
Yes,
Horizontal members are beams, and the vertical members are columns. Great. Is it clear now? Is it clear now, everyone?
yes, sir.
Good. And apart from this, there will be what? There will be slabs, then maybe foundation. Everything is in the structural members. Got it? So now, so this is known as a structural member. So now, if you go to the presentation, so in stress strain curve, remember one thing: beyond yield point, it is plastic, and before reaching yield point, it is elastic. Okay, so this is the ultimate stress. That means what? The maximum amount of stress that a structure can resist before coming to fracture. Fracture means what? It is completely broken down or it completely fails down. So this is defined as this. Okay. Do you want to take a screenshot of this, students? The previous slide. Do you want to take a screenshot?
Ajit second, sir.
Huh? Yes.
Yes, sir. That graph, that
Oh, wait. Give me a minute.
stain and
Yeah,
diagram.
yeah, yeah, yeah. Give me a minute. Okay, I'm sharing it again. Yeah. Is it clear now? Oh, sorry. Yeah. You can take a screenshot now. So this is important actually. This figure itself or this slide itself explains the whole thing. Okay,
And sir, for the ductile material,
what
that
ductile
too,
material? That
that
which one? Which
before
thing?
this you showed one PPT.
Oh, that one. That one is in the ERP now. You will get the notes. You can download it from the ERP.
Oh,
Someday.
okay, sir.
You can download it from your portal, student portal. I have uploaded it in the portal that before PPT. Okay, the ductile material, everything, the definitions and all. You'll get the notes there. It is there. Download it from there. Is it over? So now look. So now what happens? Do you have any doubt from today's class?
No, sir.
Uh, these are interesting things actually. You'll come to know eventually, but these are very interesting things. Now, can anyone say me one thing? Can anyone say me? I'm asking you a question. Wait. Now, in the stress strain graph, hmm, there is one point called ultimate stress. So, what is that thing known as? There is one point called ultimate stress in the stress strain graph. If you can see, can you say me what is that known as? What is actually that thing?
Sir, it is the stress that an a object can
Hmm.
um, bear the maximum stress.
Beard. Okay. Okay. No.
Maximum stress.
Suraj Bora, no sir. No sir. Any problem, Suraj? You can see, can't you see anything or Suraj Bora? You have any problem or any doubt? But I can't see any slide. Yeah, you just take a screenshot of this. I think so. He told me that he can't see. Can you see now? If you are done taking the screenshot, Suraj, then tell me. Write in the chat or tell me. I'll just stop sharing. Okay, fine. So Mu has said me what is ultimate stress. Can anyone else see me? What is ultimate stress?
Sir, it's the maximum stress that a material can withstand while being pulled before breaking.
Okay, so good, very good, very good. Yeah, good. So the ultimate stress is defined as the maximum amount of stress that a material can resist. Like you are applying some stress, then eventually it elongates. Now before breaking, just before rupture or failing down, what will happen? The material will elongate some amount, no? So that is known as the ultimate stress. Okay, so is it clear everyone? So we can do one thing now. I think so. It is clear for everyone. If you have any doubts, you can just ask me.